Welcome back everybody, Gary Simmons here for the Game Institute with lesson 52 of the Dead Earth game development series. In this lesson we are going to build the framework for our interactive object system. In order to understand the steps involved, let's talk a little bit about what an interactive object actually is and how our system is going to work. So every frame in its update function, our character manager is going to cast a ray through the center of the screen. In other words, through the crosshair. It'll be a short ray, about 1 meter in length. It's looking to collide with objects that are very close to the player. Furthermore, this raycast is going to be performed such that it is only searching for collisions with colliders on the interactive layer. Our game doesn't yet have an interactive layer. We'll create one of those in a moment. An interactive object in our game is really nothing more than a game object with a collider on it that has been assigned to the interactive layer and that has a script on it that has been derived from our interactive item base class. Once again, we haven't created an interactive item base class yet. We'll be doing that in a moment. The interactive item class will be an abstract base class. It exists to describe to the character manager the interface that it can use to talk to interactive items. Interactive items in a game come in all sorts of shapes and sizes, so we're going to be creating custom scripts all derived from interactive item that our character manager can communicate with, but that all have specialized code to deal with that particular item. An interactive item can be something as simple as an object that displays some text on the HUD when we move the cursor over it, or perhaps do something simple like play a sound. But other interactive items can do all manner of complex things, perhaps change the properties of various materials, send parameters into animators to trigger animations, enable and disable game objects, or all of these things combined. The interactive item base class has a very simple interface, just 2 functions. The first one is called getText. When the character manager detects that the crosshair is hovering over an interactive item, it will call the getText function of that interactive item. That function has the responsibility of returning a line of text to the character manager, which it will then display on the HUD. It will display that as the text for our interactive UI element, which remember is along the bottom of the screen. The second function exposed by the interactive object base class is a function called activate. When the character manager detects that the crosshair is hovering over an interactive item and the player is pressing the use button, which we haven't defined yet but we will shortly, well then the character manager will call the activate function of that interactive item, and it's in that function that each individual derived interactive object class will do its funky stuff, such as triggering animations, swapping materials, or disabling game objects. Another level of interactive item is the collectible item. Later on, when we have our inventory system in place, we will create collectible items as well. A weapon is a good example of a collectible item. A collectible item is not just an interactive item that we can interact with in the ways just described, but it's also got some special case code allowing us to pick up that item and add it to our inventory or drop it into the scene. So our weapons and our medkits will have scripts on them that will be derived from a collectible item class. But the collectible object class itself is derived from interactive item. We don't use any collectible items in Creeper because we don't have the inventory system coded yet, but later on when we expand Creeper out into the main Dead Earth game, we will be creating collectible objects as well. So before we write any code, let's configure our project so that it's ready for our interactive system. So the first thing we need to do is we need to add an interactive layer to our game. So I'm going to go up to the Layers drop-down in the top right corner of the editor and choose Edit Layers. Then I'm going to open up the Layers drop-down. On User Layer 15, we will type in Interactive. Press Enter, and that's all that's involved in creating our interactive layer. Now we need to configure it in the Physics Manager. So I'm going to go to the Edit menu, go down and choose from the Project Settings menu, Physics. In the collision matrix, we don't need our interactive layer to be collidable with any other layer. The only time we're going to be using the interactive layer will be with triggers, and the only time we're going to need to know about those triggers is when we do a specific raycast from our code. So I'm going to untick all of the layers so that nothing interacts with our interactive layer. I'm pretty sure I don't need the interactive layer collidable with anything, but time will soon show us otherwise, I'm sure. Okay, so now I'm going to go into the project view. I'm going to drill down into the scripts folder, and I am going to create a new folder, and I'm going to call this Interactive Items. This is where we're going to store our interactive item base class and any scripts derived from the interactive item base class. In other words, the scripts to all of our interactive items. So I'm going to right click, choose create, and I'm going to create a new C# script, and I'm going to call this interactive item. So this interactive item class is going to be the class that all of our interactive item scripts will be derived from. The interactive item class itself will just define the interactive item interface. So let's open this up in Develop and do that now. So I'll delete the start and update functions. We do need a start function, but I prefer to add that as and when I need it. I think it makes the tutorial a little easier to follow. So let's start with our inspector assign variables, and our base interactive item class only needs one. It's going to be a serialized field. It's protected so that it can be accessed easily by derived classes, and it's of type int, and I've called it priority, and by default I've set it to 0. To understand why we need a priority variable, I would like to take you through a situation that I had when I was developing the Dead Earth prototype. So in the hospital level, I had this desk, and the desk had a drawer on it that could be opened and closed. The drawer itself was an interactive item with a box collider around it, so that when I walked up to the drawer, the box collider would intersect my character manager's ray, it would detect that there was a drawer there, and then when I pressed the use key, the character manager would call the drawer's activate button to open up the drawer. Problem is, I also had an interactive item inside the drawer. In this particular case, it was a weapon, a pistol. The pistol was obviously much smaller than the drawer, and so was its collider. So when I opened up the drawer, the pistol and its collider was fully contained inside the box collider of the drawer. So even though I could see the pistol, when I did a raycast, I was still getting returned to me as the closest collider, the drawer's collider, not the pistol's. I was completely unable to pick the pistol up. So what the character manager does now is it casts a ray and asks to be returned all of the colliders that ray intersects. It then uses the priority of the interactive items to sort them, so that the interactive item with the highest priority is the one that is processed and considered to be the item that we are interacting with. We're also going to need a public property so that the character manager can inquire about the priority of our interactive item. So I'll create a public int property called priority, which just has a getter and returns that priority variable. Let's now work on the private and protected variables. Our interactive item's start function, and quite possibly many of the functions in derived classes, are going to want to talk to the game scene manager. So we'll cache a reference to this in our own game scene manager variable, which will hook up in the start function. The same is also going to be true of this interactive item's collider. I'm sure many of our derived scripts are going to want to talk to the collider or inquire about the collider. So let's store its reference in a class variable inside the start function. Let's now work on the methods that essentially comprise the public interface of an interactive item. The first function I'm going to create in the base class is a public function, but it's virtual, so it can be overridden in derived classes. It's called getText. The base class implementation does nothing, it just returns null. This getText function returns a string, so derived classes will use this function to return to the character manager the text that it would like to have displayed when this item is under the crosshair. The only other public method that we need to create that comprises the interactive item interface is the activate function. The activate function is another public function. It's virtual, so it can be overridden in derived classes, and it's called activate, has a void return type, and takes as a single parameter a character manager reference. Notice that the base class implementation does nothing, it has an empty body. These two methods by themselves comprise the public interface of our interactive items. The character manager will call the getText method of an interactive item when it detects that the interactive item is under the crosshair, and this interactive item is the one with the highest priority. The string returned from this function to the character manager will then be sent to the HUD. If this is the interactive item that is currently under the crosshair, and the player has pressed the use button, well then the character manager will also call the activate function that will give that script the chance to do whatever it needs to do to get its job done. The third and final function in this class is the start function. This isn't a public function, but it is protected so that derived classes can call it. It's also virtual, so derived classes can override it. The first thing we'll do inside the start function is we'll cache references to the game scene manager and the interactive item's own collider. We use the game scene manager class's instance property to get the instance of the game scene manager in the scene and store it in our class variable, and we also use the getComponent function to fetch this game object's collider and store that in a class variable also. Assuming we have a valid reference to the game scene manager and a valid reference to a collider, we can continue. What we're going to do in this conditional is something that we've done many times before. Remember, the character manager, when it casts that ray, will be given back the collider that the ray hit. The character manager doesn't want to talk to the collider, it wants to talk to the interactive item script that is on that same game object. However, we know that calling getComponent can be quite costly, so what we've done in the past with our AI state machines, for example, is we created a dictionary in the game scene manager and a series of registration and getter functions so that each AI state machine could store itself in this dictionary using its collider's instance ID as the key. This meant that whenever we detected we hit the collider of an AI state machine, we could simply contact the game scene manager, give it the instance ID of the collider, and the game scene manager would return to us a reference to the actual AI state machine that we wanted to talk to. We're going to implement exactly the same system for our interactive items. We will have a dictionary inside our game scene manager that stores interactive item references, and as the key, we'll store collider instance IDs. We'll create a registration function and a get interactive item function so that we can store a reference to our interactive item in the game scene manager's dictionary, and the character manager can very efficiently get that interactive item once it has its collider. So we'll assume for the time being that we've already created the register interactive item function inside our game scene manager, and inside this conditional we will say game scene manager dot register interactive item, and as the first parameter we will pass in the instance ID of this interactive items collider, and as the second parameter we will pass this, which of course is a reference to this interactive item. So that's our interactive item base class done. Let's save that off. Of course, if we go back to the editor now, we will get errors because we're calling this register interactive item function, which doesn't yet exist. So let's open up our game scene manager now, and let's add the code that's going to allow us to register interactive items with our game scene manager and fetch them efficiently using collider instance IDs. So here we are inside the game scene manager. Let me scroll down to where the other two dictionaries have been defined. You remember, we don't just store AI state machines by their collider IDs, but we also store player info objects by their collider IDs as well. And we're just going to create another dictionary like this. So let me add that. You can see this is another dictionary that has an integer key, a collider ID, but this time stores references to interactive items. I'll call this interactive items with an underscore. If I scroll down a bit, you can see, hey, there's the register AI state machine function. There's the get AI state machine function. There's the register player info function, which is exactly the same, except it's just dealing with player info objects instead of AI state machine objects. And there's the get player info function. So let's just add two more kind of duplicates of that now that do exactly the same thing, but this time with interactive items. So the function is called register interactive item. It takes two parameters, an integer key, which of course will be the collider ID, and the interactive item script itself that we wish to register. We'll first of all check that our interactive items dictionary doesn't already contain an interactive item reference with the same collider ID. And assuming that's not the case, we store the interactive item reference in our interactive items dictionary. So we can now store interactive items in the game scene manager. Let's write the code that's going to allow our character manager to get the interactive item once it knows what collider it's hit. So here's our get interactive item function. It takes a single parameter, an integer called key. Of course, this is where our character manager will pass in the instance ID of the collider that has been intersected by the ray. And the function will return the interactive item that has been associated with it. Inside the function, we create a local variable of type interactive item set to null initially, but this is what will contain the result of the search in the dictionary based on the key that we've been passed. In the next line, we use our interactive items dictionary try get value function, passing in the key, and if the key is found, then when this function returns, our interactive item will correctly reference the interactive item that has been registered with it, and then we just return that from the function. Of course, if the try get value function returned false, there wasn't an interactive item with that collider ID, then we already set item to null up here, so we'll simply return null from this function. So our game scene manager has now been correctly updated so that it can work now with interactive objects. Let's go back to the editor now and check we haven't got any errors, and we haven't. Of course, we can't test this yet because we haven't derived any actual interactive objects from this base class, and we also haven't added the code to the character manager that is going to detect when the crosshair is over an interactive object. So what we'll do is we'll add that code to the character manager now. So drilling down into my FPS controller folder, I will open up the character manager in MonoDevelop. So because we're going to need to cast a ray searching for colliders on the interactive layer, we're going to need to create a mask so that we can pass it into the raycast function that will tell it we only want it to check the interactive layer. Layer masks are passed into Unity's physics functions as integers, so at the bottom of our private variables block, I will declare a new private integer called interactive mask, and we'll set this to 0 initially, and we'll calculate the value of this mask in the start function. So let's do that now. Underneath where we store the integer of the AI body part layer index, this is where we're going to calculate our mask. So in order to calculate the interactive mask, this needs to be a mask that has only one bit set in it that corresponds to the interactive layer. So we do that by shifting the value 1 left by the integer index of the interactive layer. So I use the layer mask classes name to layer function, passing in the name of our interactive layer, and this function here will return the integer index of the layer, and we then shift 1 left by that amount, and we have our mask an integer that has a single bit set representing the interactive layer. What I'm going to do next, because it's really starting to annoy me even though it's nothing to do with what we're currently working on, is I'm going to turn off the mouse cursor in the game window when we're walking around the level, because especially when we're testing interactive objects, it's going to be really annoying if we're looking left and we're looking right and we're supposed to be focusing on the crosshair, but we're also seeing a mouse cursor whiz all over the screen. So just above where we contact the player HUD and tell it to perform a fade, I'm going to use Unity's cursor class and set its visible property to false. This will make the mouse cursor invisible, but it will still be active, and in a way this is even more dangerous because as we're moving the mouse left or right, we might accidentally be moving the mouse outside of the game view and clicking on things in the inspector and changing the settings of our scripts. So the next thing we'll do is we'll set the cursor class's lock state property to cursor lock mode.locked. So this doesn't just make the cursor invisible, it also locks the cursor to the center of the screen. So there's no way the cursor can wander outside of the game view and start selecting things that we don't want it to. Let's now scroll down to the update function and perform the raycast with that interactive layer mask that we just created. I'm going to put all of the interactive object code at the very top of our update function. The first thing I'm going to do is declare 3 local variables. The first one is an object of type ray, which we're going to use to store the ray. I'm also going to declare an array of raycast hits. When we perform our raycast, we may have multiple raycast hits returned in an array. We'll also need to iterate through that array so that we can test the priority of each one and see which is the actual interactive object that we should be interacting with. And that's where the raycast hit local variable is going to come in. It's going to represent the hit that we're currently processing in that loop. So the next thing we're going to do is create our array. Luckily, Unity's camera class has the screen point to ray function that creates the ray for us. You can see we store the resulting ray in our local ray variable. This function takes a 3D vector, although you can ignore the third component of the vector. We use Unity's screen class and its width property and divide that by 2. That will give us an X component that is in the center of the screen horizontally. We also use the screen class's height property and divide that by 2, so it gives us a Y component for our ray that is centered on the screen vertically. Before we cast our ray, we also want to know how long we want this ray to be. I'm not just going to use a fixed length. Our capsule collider is tall and thin. Therefore, when our object is horizontally in front of us, a 1 meter ray length will be perfectly fine. But as we start to look down or up at extreme angles, that might not be quite long enough. What we'll do is we'll calculate a variable ray length. So as we start to deviate from looking straight ahead, we will increase that ray length. So the more we look up or the more we look down, the longer that ray will become. So I declare a local float variable called ray length. When I'm looking straight ahead, I want the ray length to be just 1 meter. But when I'm looking at extreme angles up and down, I want the ray length to be 1.8 meters. And I wish the ray length to be linearly interpolated between those two values as the angle increases. So I use Unity's mathf lerp function for this. As the first parameter, I pass in the 1 meter length. As the second parameter, I pass in the 1.8 meter length. And as the t value, I take the dot product between the camera's forward vector and the world up vector. The dot product will be 0 at 90 degrees and 1 at 0 degrees. Therefore, if we look up horizontally or down vertically, this dot product will give us 1 and -1 respectively, whereas if we're looking perfectly horizontally in front of us, this will give us a 0. As we start to deviate from looking forward to directly straight up, the dot product result will go from 0 to 1. But as we deviate from looking straight forward to looking vertically down, the dot product will drop from 0 to -1. We want 0 to 1 when we're looking down as well, so we'll take the absolute value of the dot product using the mathf.abs function. Therefore, as we start to deviate from the horizontal and look up or down, our ray length will interpolate between 1 and 1.8. Now we have our ray and our ray length. Let's use the physics raycastAll function to perform the raycast. The raycastAll function is different from the raycast function. The raycast function returns only a single hit. The raycastAll function will return all of the colliders that the ray hits. As the first parameter, we send in our ray. As the second parameter, we send in the ray length. And as the third parameter, we pass in the layer mask. So we pass in the interactive mask that we calculated in our start function. This function returns a raycast hit array. If no objects have been hit, this will be an empty array with 0 elements. Otherwise, it will contain an array of raycast hit structures, each raycast hit telling us about the object that we've hit, and more importantly in our case, its collider. So let's first check to see if we've got any hits in our array. I check if the array's length is larger than 0. If it is, we've hit something. I'm now going to need to create a loop that's going to iterate through all of those hits so that I can find the hit that has the highest priority. I create an integer called highest priority, which I set to int .min value by default. If you hold the mouse over, you can see what that is. What we're basically trying to do here is keep track of the highest one that we found, and any hit that we find will have a higher priority than this. Also, if we do find a hit and it has a highest priority, we also want to store a reference to what is currently the highest priority interactive item. So I create a second local variable here of type interactive item called priority object that will be used to remember the highest priority interactive item that we've found so far. So let's now set up a for loop that is going to iterate through all of the hits in the hit array. Inside the loop, I fetch the raycast hit from the hits array that we want to process. Once we have a hit, we get its collider, we get the instance ID of that collider, and then we ask the game scene manager if any interactive item has been registered with that collider. And if it has, we now have that interactive item. Let's check that the interactive item that we've just received from the game scene manager is not null. We'll also see if this interactive item has a priority that is higher than the current highest priority that we have stored. Of course, when we first start this loop, highest priority will be set to min value, so any item will pass this test. But as we check all of the items in the list, we may find that we found an interactive item that has a priority that isn't as high as one that we found earlier in the list, in which case we wish to ignore it. But if this is the highest priority item that we found, we want to remember this item and its priority. I assign to the priority object, that interactive object that we've just found. We also record what the priority of this item is so that we can use it in future tests further on in the loop. We need to check whether we managed to find an interactive item. If we have, then priority object will not only be non-null, but it will also reference the highest priority interactive item. Now that we have this item, we can call the item's getText function, and then send that text directly to our HUD by using the player HUD's setInteractionText function. So this line of text is responsible for when we hold the mouse cursor over a medkit, for example, it will say medkit on the HUD. But there's also a chance that the player might be trying to use the item that is under the crosshair. So we use Unity's input manager, the get button down function, and we see if a button has been pressed called use. Now we haven't defined a button in the input manager yet called use. I'm going to do that in a moment, and it's going to be the E key. But for now, let's assume that that button has been set up in the input manager and the player is trying to use the object that is under the crosshair. In that case, we call the interactive item's activate function, passing in this object, the character manager, as its only parameter. The interactive item will now be able to do whatever tasks it has to do to accomplish its goal of being activated. So in the else clause, which remember is going to be executed if the raycast hits array has no elements in it, we say player HUD.setInteractionText, and we pass in null. And we saw when we created this function that if we pass in null, it will clear the text of the interaction text UI element, and it will also disable the game object that it's on. And that is the interactive object portion of our character manager now complete. Let's save that off. We still can't test it though, because we don't actually have any interactive objects in our scene yet. Remember, the interactive item class is just a base class, it doesn't do anything. So we're going to need to derive some scripts from it so that we can test them. And in this lesson, I'm just going to create two very simple interactive items. And in the next lesson, we'll start to do some more funky stuff with triggers and things like that. The first interactive item that I'm going to create in this lesson is the most simple interactive item you can create. I'm going to call it the info item. When you move the mouse cursor over, it simply displays some text in the HUD. This is quite useful for static objects in your scene that you want to appear to be more interactive, such as in the level we're currently working in. There are several objects such as barrels and ammo boxes and sandbags that are static objects. They don't do anything, but it would be nice if when we move the mouse cursor over them, we gave them the appearance of being more dynamic objects by saying something on the screen, such as a sandbag, an empty barrel, or a locked ammo box. The second interactive item we're going to create is going to be simple again, but slightly more complicated. I'm going to call it the interactive sound item. This is like the info item, except when you move the mouse cursor over it and you activate it, it will make a sound and play activated text. This is good for, let's say that you have a door in your level. It's static, alright? It's one of those doors that stops you leaving the game zone. So it's never intended to open, but you want it to seem like a dynamic object that might open. You could put an interactive sound script on it. So when we walk up to the door and the mouse cursor is pointing at the door, it would say door. But when you press the mouse button, it would make the shaking sound of a locked door, and then the text would change to say something like, the door is locked. So those are the two interactive items we're going to create now to test our system. So let me go back to the editor first and check that we haven't got any errors, because we've just added quite a lot of code to our character manager. And no, everything seems to be fine. Oh, actually, before we do anything, we also need to define the use key in our input manager. I've got the input manager active at the moment, but if you've forgotten how to get there, go to the edit menu, go to the project settings menu, and choose Input. The last button that we added to the input manager was the one that controls the flashlight, and this is the F key. So actually we can do this quite easily by just increasing the size of the controls in our input manager to 21. And by default, what's really cool about this is when Unity adds an additional element to the end of this axis array, it makes it a duplicate of what the previous last element in the array was. So we've got a duplicate of our flashlight here. So we can just change the name to use with a capital U and change the positive button from the F key to the E key. Okay, so that's our input manager set up to use our interactive object system. Let's now create those two simple interactive object scripts. So I'm going to drill down into my scripts folder and into my interactive items folder, and I'm going to create a new C# script, and I'm going to call this interactive info. The interactive info item is an interactive item that simply displays some text in the HUD. So let's double click on that and open it up in MonoDevelop. I will move the curly brace onto the next line, and I will get rid of the start and update functions. We will not need them. Also, because this is an interactive item, we need to derive it from the interactive item class and not directly from MonoBehavior. Like so. This very simple class requires only one variable, which will be serialized so that we can set it via the inspector. This is a string called InfoText. It will allow us via the editor to type in the text that we would like displayed in the HUD when this object is under the crosshair. The character manager will call the interactive object's getText function. So we need to override that in this class so that our getText function will return this text back to the character manager. So as you can see, I've overridden the getText function, and this time I just return InfoText. Notice I'm using the override modifier here because we are overriding the getText function in the base class, which does nothing. We don't have to worry about writing any code in this class that's going to register its collider with the game scene manager, because this is derived from interactive item, and interactive item start function already does that for us. Okay, so let's save that off. Go back to the editor, and what we want to do is test our interactive info script and also test our interactive system in general. So what I'm going to do is, looking around the level, you can see we have several objects such as these barrels, which are the ones I think I will concentrate on first. Actually, I'll call them canisters. That's a better word. And we've got quite a few of them around the level. Now, these canisters are not separate objects, okay? They're baked into the scene geometry, but that doesn't mean that we still can't make them simple interactive objects. So I'm going to go to the Game Object menu, the 3D Object submenu, and create a new capsule. Holding Control and Shift, I'm then going to drag it near me so that my capsule collider is in my location and ready to be lined up with the canisters. So all I'm trying to do really is create an object with a capsule collider on it, where the capsule collider bounds closely the shape of the canister. It's this object we're going to put our interactive info script on, and will be the interactive object. So what's funny about it is, technically speaking, the object we think we're interacting with, one of these canisters, it's just a kind of background graphic that's baked into the scenery, but it's the collider we're interacting with which makes the player seem as if it is interacting with the object. Now, of course, we don't want the mesh of the capsule rendering, but I'm going to leave it in place for now because it's really good for sort of lining up the size and the position of this object when we're trying to line it up with all the canisters. And there's lots of canisters in the level. So in a moment, what I'll do is I'll prefab this item when we have it exactly how we want it, and then we can easily create instances of that object in the scene and place them in the positions and orientations of all of the other canisters in the level. So I think that's about right size-wise. It doesn't need to be exact. So next up, with our capsule selected, I'm going to assign it to the interactive layer, and I'm going to add to it an interactive info script. As you can see, the interactive info component has that priority integer exposed from the base class, and then the info text property, which we want to set to canister closed. Right, it's a closed canister. Next up, I am going to rename the capsule in the hierarchy and call it canister. And then I'm going to drag this game object from the hierarchy into my prefabs folder, like so. And then with the instance in the scene, I've just realized actually that canister is spelt now with one N. There is a form of the word with two N's, but it's now considered obsolete. So I'm going to rename canister to contain just one N. And then the canister instance in the scene, I'm going to, for now, turn off the mesh renderer, and then I'm going to press play and test if it works. Okay, here goes. So let's walk up to that first canister and see if we get some text on the HUD. Hey, look at that. It's telling me it's a closed canister. Okay, of course, none of the other canisters will do that because they don't have a collider on them or an interactive info script on them. So what we can do now is we can just drag multiple copies of our canister prefab into the scene. So we'll put one over here by the open canister. Just to remind you, it looks like that. There you go. Once again, turn off the mesh renderer. We could go back afterwards in a separate pass and visit all of the canisters in the scene and actually remove the mesh renderers and the mesh filters. But for now, when we're dragging the prefab in, it's really handy to have that stuff on there so we can see that we're lining things up correctly. Okay, so we have this canister which is open, so we're going to change the info text of this one so it says canister open. Oh, I've also noticed I've used the double N again there for canister. I probably did that on my other canister object as well, didn't I? Yes, I did. And I'm going to rename this canister just canister, so all of my game objects are called exactly the same thing. I'll just drag it down there. So all of my canisters are together in the scene hierarchy. And then finally, I'm going to duplicate the first canister, the closed canister, rename it canister again. And then I'm going to move that over, after I've enabled its mesh renderer, to the canister that's been knocked over and is on the floor. And we'll just line that up as well. So I'm going to go into rotation mode. Something like that. Let me get down so I can see what I'm doing. That should be close enough. So let's press play now and see if we get the 3 different readouts for our 3 different canisters. Oops, I left the mesh renderer on the 3rd canister, so let's disable the mesh renderer on that one. Press play again. Go up to the first canister and it tells us it's a closed canister. Go up to the second canister, it tells us it's a closed canister. And let's try that 3rd canister. Oh look, and it tells us it's an open canister. Pretty cool stuff, huh? So as you can see, we have quite a few of these canisters in the level. We have some in this middle room here. Another batch over here. A few more over here by the rip in the fence. Wow, we've got quite a few of them. And some in this room here. So what I'm going to do is pause the video now, and I am going to make canister interactive info objects for all of the canisters in the level, okay? And I suggest you do the same if you're following along with me. And I'm back, having encapsulated all of my canisters. And as you can see at the moment, all of the interactive items that I've created for our canisters, I've left the mesh renderers on. And if you look in the scene hierarchy, you can see all of the canisters I've created. So I'm going to select them all, and I'm going to disable the mesh renderer. And I think what I'll also do is I'll create a empty game object that can act as a container for all of these canisters so they're not clogging up our scene hierarchy. So I'll create an empty game object, and I will rename it canisters. Like so, and then I will select all of those canisters and make them children of the canisters container game object. And there you go, there's all of our canisters done. So the next thing we'll do is we'll work on our interactive sound script, which is going to be a slightly more complex form of interactive object. And like I said, this is going to be an item that when we walk up to it and it's under the crosshair, it's going to give you some information just like our standard info interactive item. But when you activate it by pressing the use key, it's going to make a sound, and it's also going to display some different text while it's activated. So let's do that now by drilling down into our scripts folder, our interactive items folder, and creating a new C# script, and we'll call this interactive sound. Like so, and we'll double click that and open it up in MonoDevelop. We'll delete the start and update functions, we don't need them, and we'll move the curly brace onto the next line because we're not savages. And of course, because this is an interactive item derived class, the base class needs to be interactive item, not monobehavior. So this class is going to need a few serialized members that show up in the inspector. The first, of course, is going to be the text that we wish to be displayed when the crosshair is over the object, just like the previous script that we've written. And what I've decided to do is use the text area modifier so that it shows up in the inspector as a multi-line text box, which will allow us to format paragraphs of text if we need to. And in fact, I think I'm going to go back to the interactive info script and add the text area modifier there as well. So just like the previous script, the info text is a string that will be displayed in the HUD when the player's crosshair is over the object. But we also need another string that will be displayed when the user parameter activates the object. So as you can see, this is another private string that I've called activated text, and once again I've used the text area modifier so that it shows up in the inspector as a multi-line text box. The next member is a float that I call activated text duration, which I've set to 3 seconds by default. This is how long the activated text is going to be displayed on the HUD after we've activated the object before it changes back to the info text. Now originally what I did in Dead Earth is I didn't have the activated text duration member, and I instead tied it to the length of the audio clip that was being played. But I soon found out that that wasn't a great idea, because I had certain objects that when I activated them made really small sounds, such as the PDA that plays back messages. It had a very short sound, just like a beep beep, and that wasn't long enough to read the activated text. So I decided to decouple the length of the audio clip played from how long the activated text is on the screen. So we're also going to need to know what sound to play, and just like the rest of our system, we're going to use an audio collection for specifying sounds. This will of course allow any item to specify a collection of sounds that are randomly selected. So this means in the case of a locked door, for example, every time we activate or try to activate it, we're going to get a slightly different locked door sound, which will make it sound more organic. And whenever we use an audio collection, we also need to specify the bank within that audio collection that we wish it to use. So I also serialize a private int called bank. That's the inspector assigned serialized members. Now let's move on to the private fields. We're going to use a coroutine to play a sound from the audio collection and essentially block another coroutine from being spawned again until that clip has stopped playing. So what we're doing is we're going to spawn a coroutine, we're going to store the reference to that coroutine in this IEnumerator variable, and we know that we can only activate the coroutine again once this coroutine variable is null, and that stops us spawning multiple coroutines where we would have sounds overlapping. The next variable I need is going to be used internally to keep track of when we need to hide the activated text. This is a float called hide activated text time. When we activate this item, we will fetch the current time and add on to that the activated text duration, 3 seconds in this example, and store that value in the hide activated text time. We then know that we need to display the activated text from within our getText function whenever it's called until the current time is larger than the hide activated text time. If that was a little hard to follow, I'm sure it will make a lot more sense in a moment when we see the code. Okay, so as you would expect, we need to override the getText function to provide bespoke functionality for this derived class. So the first thing we'll do inside this function is determine whether we need to display the activated text. The first condition is that our coroutine is currently running. If our coroutine variable isn't null, then it means the coroutine is running, that sound is still playing, and we should definitely display the activated text. But if it was a very short sound and thus a very short coroutine, we don't want the text to disappear too soon. So we also say, or if the current time is less than the time that we are supposed to next hide the activated text, which you'll see calculated in a moment in our activate function. If either of these conditions are true, we need to return the activated text and not the standard info text. So we return activated text. Otherwise, we return the standard info text. Let's now override the activate function. Remember, the activate function takes as a single parameter the character manager, but we're not going to be using that parameter in this simple function. The first thing we'll do is we'll check that our coroutine variable is null. If it isn't null, we don't wish to start the coroutine that's going to play the sound, and we simply wish to ignore the request. However, if the coroutine is null, then we know we're about to display the activated text, and we need to calculate the minimum time that the activated text should be displayed for. We do that by getting the current time and adding onto that the activated text duration, which by default is 3 seconds, and we store that in our hide activated text time member variable. Now that we've calculated the minimum time that the activated text should be displayed for, we need to start our coroutine. We'll first store a reference to the coroutine in our IEnumerator variable. The function is going to be called doActivation, and then of course we will call Unity's start coroutine function to actually start our coroutine. So let's now write the doActivation function. As with all coroutines, it has to return an IEnumerator. It's private and it takes no parameters. The first thing we'll do is make sure that we do have a valid reference to an audio collection, and that we also have a valid reference to an audio manager in the scene. Otherwise, we just break from the coroutine. Next up, we wish to fetch a random audio clip from our audio collection using the bank that we set via the inspector. If we get a null clip returned, once again, we just break from the coroutine. There's nothing we can do. However, if that's not the case, we use the audio manager's play one-shot sound to play our audio clip. I'm sure you're aware of the parameter list by now. We take the audio group, the volume, the spatial blend and the priority all directly from the audio collection specified. But as the second parameter we pass in the clip that we fetched from the audio collection up above. And as the position to play the sound we pass in the position of this game object, the actual interactive sound object. With the audio clip now playing, we now wish to chew up time and wait in this coroutine until the clip has finished playing. So you can see I do a yield return new wait for seconds, passing the clip length as the number of seconds we wish to wait before continuing execution within this function. Finally, after the sound has finished playing, we set coroutine to null so that we know we can instantiate another coroutine again if the user should press the use key again. And that is our interactive sound script done. Let's make sure that we save that off and then go back to the editor and just check that we haven't got any errors. And we haven't. So now we need to test this script out. So what I'm going to do for this test is I'm going to use the graphics of these ammunition boxes. I don't know if they are ammunition boxes, they're probably not, but I'm going to pretend that they are. We have a couple of them spread throughout the level, I believe. Yeah, we've got some more over here. And what I want to happen is when we go up to it, I want it to say it's an ammo box. And when we try to open it by pressing the use button, we're going to hear like a locked door sound and the text is going to change to say locked or ammo box locked. So we're going to need a sound for that. So if you download the Lesson 52 resources, inside that folder, I've unzipped it to my desktop here, there is a sounds folder and there is a sound in there called door sound locked. And I'm going to drag this into the scene sounds folder inside my sounds folder like so. Then I'm going to select it and via the import settings I'm going to change it to PCM, we don't want compression, and also force it to mono and click apply. So now we need to put this in an audio collection, so I'm going to select my audio collections folder, go to the assets menu, choose create and then select audio collection and I'm going to call this door locked sounds. Now what audio group does this need to be on? Let me go up into my root assets folder, select my audio mixer and then bring up the audio mixer tab. We want this to be on the scene audio mixer group, okay? So it's scene spelled with a capital S. So once again, drilling down into my audio collections folder and selecting my door locked sounds collection, I'm going to assign it the scene audio group. We want the volume to be quite subtle, so for now I'll turn it down to something like 1.2-ish. We want this to be a 3D sound and we'll leave the priority at 128 and it needs to have one clip bank and that clip bank needs to have one sound in it, although in the future we can bring in multiple door locked sounds and add them to this collection to get more randomness, but for the test this will be just fine. So let me lock the inspector of our audio collection, step back up into the sounds folder, down into the scene sounds folder and drag our door sound locked WAV file into that bank within our audio group. Okay, so what I need to do now is create an empty game object that I can use to encompass these ammo boxes. And rather than create a separate interactive sound object for each of the boxes, I'm just going to encompass the whole ammunition pile in one collider. So I'm going to go to my game object menu and I'm going to choose to create a new 3D object of type cube. And I'm going to line it up so it's roughly bounding the ammunition box. So let's rotate it around its y-axis a little bit like so, to about there. Open it up so it bounds the ammo box. Because there's stuff in the way of this ammo box, we probably want to be a little bit more generous with the collider so that we don't have to be right on top of it before it registers as being an interaction. So I'll make it a little bit wider. I'll set the X scale to 2.7. I'll set the Z scale to 2.4 like so. Yeah, something like that. Okay, so I'm now going to turn off the mesh renderer temporarily. I'm going to rename the cube game object in the hierarchy and call it ammo boxes. Like so, and I'm going to assign our ammo boxes game object to the interactive layer and also add to it our interactive sound script that we've just written. As you can see in the inspector now, the two strings show up as text boxes, so we will say ammo box like so, and then for the activated text we'll say ammo box locked. For the sound duration we'll leave it at 3 seconds for now and we'll assign it our door locked sounds audio collection, being sure to leave bank at 0. Okay, so let's see if this works. So as you can see, it says ammo box on the HUD, and when I press the E key, it comes up ammo box locked. Press it again. But if I try pressing the E key multiple times while the sound is still playing, it doesn't let me, which is exactly what we want. Okay, so that works. So we've got another ammo box in the level, I believe. Where is it? Over here. So what we'll do first of all is we'll select our prefabs folder, and we will prefab our ammo boxes object. Actually, for the prefab, I'll turn on the mesh renderer again so that when we drag a new instance of this into the scene, we can see exactly what it looks like, and then we can just turn off the mesh renderer on the individual instances. Yeah, that's probably about right, isn't it? Yeah, we'll leave that there. Turn off the mesh renderer, and let's see if there's any more in the level. Don't think there is, actually. What about, oh yep, there's another one in here. So once again, I will drag in a copy of our ammo boxes prefab, rotate it around, yeah, and move it out to about there. I think that's the last one. So now let's select our 3 ammo boxes. Actually, let me move those in the scene hierarchy. So I'll grab ammo boxes 1, ammo boxes 2, drag them down to above ammo boxes, and I'll get rid of the numbers on the end of those game object names, don't like it. And then I'll select them all. And with them all selected, I'll make sure that I turn off the mesh renderers. Then let's press play again and check that they all work. Ammo box 1. Actually, let me stop that. I do believe that the sound is a little bit quiet, so we'll drill down into our audio collections folder. We'll select our door locked sounds, and we'll just bump up the volume to about 0.5 and press play again. It should be quite a bit louder probably than our footsteps. Yeah, actually looking at those, they look like they're made of cardboard, and they don't look like they're ammo boxes at all, but don't worry, we know what we're trying to do and what we're trying to represent. Okay, that one works, and we'll just go and try the other one, although I think we all know it's going to work. Oh, there's another ammo box there that I need to do. I forgot about that one. Okay, so I've got one more ammo box to do, and then we're done. So where is it? It was over here. So I think what I'll do is I will select that one that's closest to me, duplicate it, temporarily enable its mesh renderer, and just drag it over here, because it looks like it's more or less aligned. And I suppose we better give it one more test. And obviously I forgot to turn off the mesh renderer, but it did work. I still think we can do with turning up the sound though. So once again, turn off the mesh renderer there. Finally select our door locked sounds. Turn up the volume a little bit more. Let's try that. Canister closed. Yeah, we're not getting any guns out of there. Cool. Okay, so that all works. So I think I'm going to leave it there for this lesson. What I think you should do, and I'm going to do between now and the next lesson, is put some interactive info objects on some of these other objects in the scene, just because it makes the level seem more alive. So we could create one for piles of tires. This would be a simple info object so that when you go up to it, it just says tires. You could also do some on these petrol cans. Could even do some on the cones, and perhaps even do one on the battle bus itself, so that when you move up to it, it says it's the battle bus. Is there anything else? I mean, you could really go overboard on this, right? I mean, you could go up to here and have a box collider on that wall that says gun chart. You could say map, scrap metal. I'm not going to do all of these, but you certainly could do them. We won't do things like the computer, because we're actually going to be using that as a more complex interactive object in possibly the next lesson, or if not the lesson after that. But yeah, go wild. Use our new interactive system and start making your level seem a little bit more alive. Thanks for listening, guys. I hope you enjoyed the lesson. I will see you next time. Bye-bye now.